Hello and welcome to our video tutorial. Today we're going to look at Unit 2, Lesson 5, the domain and range of a function. Please remember to pause or rewind the video as needed. In the fluency section, we're going to explore the concepts of domain and range, but we're also going to explore different ways of notation, how to notate a set of numbers differently. There is called set notation, interval notation. Sometimes set notation is called roster notation because it looks like a list or a roster. And so we're going to be exploring different ways of notating our list of values. We're going to take a look at a piecewise function again. We saw one at the end of lesson number 3. And we're going to look at a piecewise function again as a way of examining the domain and range of that function. Finally, we're going to take a look at domain and range in our applications with regard to what's called average rate of change. Average rate of change involves the time it takes to change some particular value. Okay, and so we'll be looking at that over our application and reasoning section. So please, again, remember to pause or rewind the video as you need to. Okay, let's begin. Domain corresponds to the set of all x values. Range corresponds to the set of all y values. And here's an easy way that I always remembered this when I was younger. X comes before y in the alphabet. Well, D comes before R in the alphabet. So in other words, domain comes before range, X comes before Y. So domain is the set of all X values, range is the set of all Y values. Now, we're going to be stating domain and range here, but before we do, let's review interval notation, okay, so that we can get a handle on not just interval notation, but inequality symbols too. So just to kind of review, if I have a number line, and on that number line, so here's x equals 0, 1, 2, 3, 4, -1, -2, -3, -4, like that. Now, if I was talking about x is greater than 2, well then, notice the symbol greater than means all numbers greater than 2, but it does not include 2. So it could be 2.1, 2.01, but it cannot include 2. So on a graph, we would include that with an open dot or a hole, and we would draw, a line or an arrow going in that direction. So holes indicate when we do not include our value. If it were x is greater than or equal to 2, well, then I have to include 2 also, and I'll do so by darkening that hole in with a circle. So using inequality notation is one way to do this. Okay, now, let me erase some of this. What if I wanted to talk about the set of numbers between 2, -2, and 3, not including -2, but including 3. So not including -2, I would write a hole there at 2, and I would make a dot here at 3, and I would darken in the line. That would represent the set of all numbers in between right there. Okay. Now, how would I represent that in interval notation? Well, x would be what? Less than or equal to, so less than or equal to 3, while simultaneously being greater than -2. So I can write that in what's called interval notation. Now, I could also write interval notation as a set of parentheses or brackets. Okay, if I do not include the number, then I have a parenthesis on the outside. And I'll put a little comma to separate the endpoints of my numbers. So 2 and 3 are the endpoints of my interval. But over here, since I'm including the number 3, I'm going to put a bracket around that. So we're going to be using bracket notation as a way, this is another way of doing interval notation. So let's try and apply that to our domain and range problems below. In letter A, we have a graph of f of x. Well, the domain, remember, is the set of all x values, range is the set of all y values. So the x starts where? 1, -1, -2, -3, -4, -5 is where the graph starts. So the graph goes from -5, well, I'm going to write this out a different way. It goes from x equals -5 to x equals 1, 2, 3, 4. Okay, so that means x is less than or equal to 4, because it includes 4, while simultaneously greater than or equal to -5. Okay, so that's one way we can do the interval notation on the domain. Domain is the set of all x values for our function. Now you could write this in another way, and that's to put the endpoints, -4, -5, and 4, -5, comma 4, but since I include both of those endpoints in my function, I would bracket it off like this. So both of those are ways of writing the interval notation for the domain. Now the range is the set of all y values. So you're looking at from the lowest point of the function, right here, to the highest point of the function, right here. That's the range of the function. So what would that range be? Well, what's the lowest point? That's -1, 2, 3, 4, 5. So it goes from, and you always, by the way, go from the lowest to the highest, just so you know. So it goes from y equals -5 to y equals 1, 2, 3, 4, +5, to y equals +5. And so you can go ahead and write this as x being, sorry, not x, y. So y being less than or equal to 5, but simultaneously greater than or equal to -5. And if we put it in bracket notation, we'll put our intervals, -5 and 5. We include both of them with brackets on the end to indicate that we're including them. Now, in part B, you're going to explore domain and range from the point of view of matching your x values with corresponding y values. Okay, so what's our domain? Well, our domain, this time we're going to write it in set notation. The way to write it in set notation is write a bracket, and we're going to list our numbers. What are our numbers? -4, 0, and 6. Whoops, sorry. Like that. That's our domain, our set of x values. Well, the other way we can write the range in set notation. That's what this is called right here, set notation. Sometimes I've seen it called roster notation because it looks like a list or a roster. This, by the way, is called interval notation. And interval notation, you can write it one of two ways, with inequalities or brackets and parentheses. Okay, braces in parentheses. Okay, so then the range would be the set of values that includes 12, 18, and 40. Okay, now is this a function, yes or no? What makes a function? Every input has its own output. Well, do you see how 6 has 2 different outputs? The answer is no. 6 has 2 outputs. A function is only a function if an input has one and only one output. Number 2, consider the piecewise linear function given by the formula f of x is equal to 2x minus 2 minus 3x for all x values that are in between 1 and negative 1. So this means x values in between 1, negative 1, and 1. Okay, so to be greater than negative 1 but less than 1, it means you're in between negative 1 and 1. And then you're going to use this part of the function, x minus 2, for all x values that are greater than 1 but less than or equal to 3. Okay, so that's what that means. And then what we're going to do is we're going to be able to determine the domain and range. So how can we plot this? Well, my suggestion would be go ahead and plot a set of y values, x values, and then we're going to figure out their y values. In other words, we're going to set up a chart, kind of like we did in our last lesson. So x, okay, and then what are my x values? So I can go x, let's just choose some random x values. We can go negative 1. Maybe 0. 1. 2. And I guess maybe one more, 3. So just basically you want to choose a small set of x values. And what you're going to do now is we're going to do the rule. So the rule is, let me go ahead and fix my chart here. So the rule is going to depend on what part of the function it was. So for instance, negative 1, so between negative 1 and 1, including negative 1, I'm going to use 2x minus 3. So I said 2x minus 3, 2 minus 3x. So 2 minus 3 times negative 1 is the same as 2 plus 3, which is 5. This is our xy coordinate pair. So this first one would be negative 1, 5. Okay, let's do the same thing. Now 0 is also in between negative 1 and 1. So we're going to go 2 minus 3 times 0, which would be 2 minus 0, which would be 2. So we're using the point 0, 2 right here. 1 is also included in that interval. So we're going to go 2 minus 3 times 1, which would be 2 minus 3, or negative 1. So we're graphing the point 1, negative 1. Okay, now 2 and 3 are both in this interval here between 1 and 3. So we're going to use 2 minus 2, which would be 0. We're graphing 2, 0. And we're going 3 minus 2, which would be 1. And we'll graph the point 3, 1. So let's go ahead and graph those points. I'll graph them with a different color. -1 up 1, 2, 3, 4, 5. There's our first point. 0, 2, 1, -1. Okay, and then you're going 2, 0, and then 3, 1. So this literally is our function. This little thing right here. Okay, that little graph kind of looks like like a backwards check mark almost. Okay, now what's the domain and range of the function? Well, the domain is the set of all x values, right? There's your domain right there. How wide is the function? The range is the height of the function, which would be how tall is the function. Okay, so your domain goes from what? -1 to 3, and it includes both of them. So from -1, x is greater than or equal to -1, but it's less than or equal to 3. And you could write that as -1, 3 with braces. Okay, the range, similarly, the height, you're going to start at the lowest point, which is down here. Okay, and the lowest value would be y is greater than or equal to -1. But the highest point is going to be this part right here, which is up to 5. So it's less than or equal to 5. And so we would write that as -1, 5 with braces around because we include both -1 and 5. Scrolling on to part 3, okay, is our application section and our reasoning section. The following graph represents the height above the ground versus time as a resort, at a resort as Thomas rides his favorite ski slope. State the domain and in your own words what the domain represents. Well, what's the domain? The domain is the set of all x values. Well, x values in this case would be time. So look at the graph. How long is the graph all the way till 6 seconds? So it includes 6, it includes time. So time would be less than or equal to 6 seconds or greater than or equal to 0 seconds. Okay, and you could write that as 0, 6. Okay, or basically, what is this another way of saying? The time interval is from 0 to 6 seconds, from 0 to 6 seconds. So I keep saying seconds, I'm sorry, minutes, from 0 to 6 minutes. Okay. Now, what does the domain represent? Well, it represents the time this would be the time going up the mountain. This would be the time going down the mountain. So it represents the time going up and down the mountain. Now, I don't know if any of you have ever been skiing or snowboarding before. I have many times, and I know it takes more than 6 minutes just to get all the way to the top of something, much less on the run on the way down. But pretty low estimate of time there. It definitely takes a lot longer than 6 minutes. But in any event, in this particular example, it takes 6 minutes to go up and down the mountain, according to that. So state the range, and in your own words, explain what the range means. Well, the range would be how tall the function is. Well, in this case, it's how tall the mountain is, right? It's the how high you get to and how far you're going from the top. So what would the range be? Well, the range is lowest point of 0 and a highest point of, this would be 90 meters. So we could say y is less than or equal to 90 meters and greater than or equal to 0. Or You could write it as 0, comma 90 with braces around it. And it represents the height of the mountain, yes, but it represents the rise in height. From the bottom. What might Thomas have been doing during the interval from 0 to 2 minutes? Well, if you notice, it's a constant rate of change. So one way we can find that constant rate of change is by taking a look at the distance that you travel and the time it took to get there. Okay, that's how we can find the average rate of change. So what could it represent? Well, it could most likely it represents Thomas on the ski lift. Right, going up the mountain. Okay, what is this average rate of change? Well, average rate of change refers to, in this case, an average speed is really what we're looking at here. The average rate of change is the average rate of change of height over time. So how do we do that? Well, it's the change in height, over change in time. So the change in height would be a total of 90 meters. So 90 minus 0, which is 90 meters. Okay, and the change in time, well, that would be 2 minutes. So 2 minus 0, or 2 minutes. Dividing the two, we get 45 meters per minute. What might Thomas have been doing during the interval of 2 to 6 seconds, meaning this part right here? Most likely we're talking about he's coming down the mountain for sure. So is he coming down? Hopefully he's skiing down and not falling down, but basically he's coming down the mountain. Okay, and what's his average rate of change there? It's the same idea, change in height over change in time, but this time the change in height is 0 minus 90 because the final height is 0, the initial height is 90 all the way at the top. You're going in a negative direction, you're going downwards. So that's going to be negative 90 meters over 0 minus 4 seconds, because we're talking about from 6 seconds is the final time, 2 seconds is the initial time. So from 6 to 2, which would be 4 minutes. Okay, and dividing those two, you'll get about negative 22.5 meters per minute. All right, and in our final question, number 4, it says the graph below represents the height of a ball over the interval between 0 and 8 seconds. So time is greater than 0 seconds, but less than 8 seconds. So basically between 0 and 8 seconds. After how many seconds was the ball 12 feet off the ground? Explain your reasoning. Well, it was 12 is up here. It was never 12 feet off the ground. Okay, and the reason I know that is because the maximum height, according to this graph, is 11 feet right here. What does your answer indicate about the range of this function? Well, the range would be from 0, so the range would be your y values, your height, which is greater than or equal to 0, but less than or equal to 11. It's capped at 11, okay? And this does not include a height of 12 feet off the ground. Okay, basically what that means is the input of this time right here, which is 4 seconds, would not have an output. So you have an input with no output. Therefore, it's not part of the range of the function. Okay, I hope you found this video tutorial to be helpful. Again, please remember to go back and rewind or pause as you need to. Thank you and see you next time.